Our next speaker is Muthu Nedumaran from Malaysia. I succeeded in getting some secrets about him, not mentioned in his biography. He's a stage, he does stage plays, he's into acting, and he does, he's a speaker motivation act, and also he does talk shows. And a lot of Indian fonts on the Adobe platforms are created by Muthu. Apple platform, sorry. Okay, so his presentation, Sketching, Shaping, and Proofing Fonts, invites us to look at font making in three broad stages that he will explain right now. Welcome.
Okay. Thank you. Thank you very much. I was supposed to be at a talk show today on Malaysian TV. I gave that up because of ATypI. I thought this was important. Okay. Can we have this machine projected? Okay, thank you. A little nervous. It's my first ATypI presentation. So I'm just going to consider this as a stage play, acting in a drama. And this is going to be the first talk on Brahmic scripts, or Indian and South Asian and Southeast Asian scripts. We've heard so much about Chinese CJK talks this morning. Wonderful presentations. I learned a lot from the speakers. I'm quite familiar with CJK input methods, not so much on the fonts. I think they were all flying quite high. Very interesting topics, very interesting issues, and very interesting solutions that they came up with. I'm going to go very basic. Roger is watching me. He says, I need to understand what you're talking about. So this is going to be like a safety demonstration for people who are new to Brahmic script families, or in South Asian and Southeast Asian scripts. We call them Brahmic scripts because they all originated from a script called Brahmi, and they're all descendants of that script. So I've been working on Brahmic scripts for only about 40 years. So unlike Latin, or even CJK for that matter, we need a process before any font can be rendered legibly on the screen. There's a process called shaping, and that's what I'm going to be talking about. There were some issues. I had some problems. There were no tools. I wrote some tools, and I'm going to demonstrate those tools for you. And before I end the presentation, I'm going to also talk about a crazy idea that I'm thinking about and sharing it with you for the first time, and hoping to get some feedback throughout the conference. Okay. This is a typical flow. I mean, it could vary from people to people, or foundries to foundries, but typically this is what we do. We sketch, we draw, we export, we proof, and then we ship the fonts. I mean, not so simple, but you can, not so easy, yeah. But roughly, if you categorize them, that's the reason why I showed that is because there's one additional step for the scripts that I'm going to talk about, South Asian, Southeast Asian, or even Arabic scripts, which I'm quite familiar with. There's this thing called shaping. Without this shaping process, the text is not legible. It will not make sense to the reader, right? That's absolutely critical. It's part and parcel of typography for the scripts. They all require shaping. In any font, the glyph count is a lot more than the character count. Shaping involves reordering of glyphs, substitution, insertion, positioning, and all that work, which I'll talk about shortly. And one script may support more than a language, especially scripts like Devanagari, which probably is used to write about a dozen-odd languages in India. Bengali, which is used to write Assamese, and a few other languages. There are also optional forms. Tamil, for example, has got historical forms that were changed just about 50 years ago, and some of the old forms are still used. I still write them in the old forms. And those are features that need to be supported. I'm going to talk about this in particular, reordering, substitution, insertion, just to demonstrate the complex, why these are called complex scripts. Assume that these are all characters, because if I put real characters, it may not make sense to you. So these are different characters, right, and different shapes. Sometimes two characters get substituted into one. The second character will not make sense if it stands alone, so you get substitution. Sometimes a character gets inserted. You got split vowel signs which will appear on either side of the base glyph, so you need to split them first, and then reorder them, right? And then you also have what we call matras, or vowel signs, or diacritic marks, similar to diacritic marks. They're not diacritic marks, but they have meanings, and they go sit on top or bottom or the side or somewhere to the left or right side of the glyphs. These are all some very simple explanation. Like I said, it's a safety demonstration. There's a lot more that happens, but this is roughly give you an idea of what happens in the shaping process. And this is a real-world example. If you give, this is a Unicode text, genuine Unicode text before shaping. So if you go, this is in Khmer, in the script used to write the Khmer language in Cambodia. You take this and give it to someone in Khmer, in Cambodia, they will not make sense. It doesn't make sense. There's definitely no dotted circle in our character sets. Dotted circle is not a character in any of these languages. And that plus sign below the dotted sign, it will not make sense to a common user. We know as engineers that it's a Virama sign, but others will not know. So that has to be shaped into something like this. So you see reordering, glyphs changing form according to context, some going on top. This is one cluster. It's not even a word. It's one cluster in a word. So that's what shaping process is. Without this shaping process, nothing works in these languages. So for shaping to work, we add OpenType, we add GPOS, and GDEF is usually, the glyph definition is usually generated by the tool themselves, so we don't have to worry about it that much. But GSUB and GPOS is something we have to do. This is a very simple GPOS rule in some of my fonts. It's very, very simple. It can be as complex as this, right? This is one of the simplest Indian scripts, which is Tamil, and requires the least amount of shaping rules, and that itself is so much, right? So then we export, and then we proof, right? We have to make sure that the shaping works. Now, most of the tools that we have, or have been using, I had to work with, are tools that will tell you what's in the font, what the font will do, but it will not show you what is required of the script. There are two different things. The paradigm is very different in this region, because just because you have drawn all the glyphs that are required by the Unicode standard, it doesn't mean that the script is going to work for the language. And just because you have done something for Hindi, it doesn't mean that that Devanagari is going to work for Marathi, which uses the same script. So it was a nightmare to test and prove that my font works for the languages that I'm targeting. So what's required in the font is something that was missing. There were no tools that helped me. And because there were no tools, I had to do it myself, right? When I did this about 20 years ago, it was for a shaping engine called AAT, which is still very popular. It's called, not very popular, but still used, called Advanced Apple Typography. It's also supported by another engine called Hibizcus, which also powers some of Adobe products, all of Android, even Microsoft's browser is supported by, shaped by the Hibizcus engine, which supports AAT. Apple, of course, supports AAT. But don't worry about that, we'll come to that later. I want to be able to report differences between builds. As I said, what's in the font versus what the font should have. Collection of script, language-based data, script-based. There's a lot of script grammar-related rules in these languages. I want to inspect all the components that institute. The cluster is a term that is very commonly used in Brahmic scripts or South Asian scripts. A cluster can consist of 2 up to about 12 characters. And they all actually stack one on top of the other. Some get composed into a single glyph. They'll do all kinds of stuff, but that's just one cluster. When things don't work, I want to be able to trace the shaping process and see where I have failed, right? And then after that, finally render random words in the language and see if they all work okay. I mean, that's basically what I needed to do when I built the fonts. So I built a tool called Hibizcus, which is available on the Apple Store for free. It's open source, it's in GitHub. And I'm going to demonstrate that to you now. Okay, that's Hibizcus, showing one of my fonts that I'm still developing. There are lots to talk about it. In the interest of time, I'm only going to talk about the shaping-related work. You can look at the font view. You can drop another font there and compare the differences. So when I deliver fonts to my vendors and they come back with some bug reports and I fix it, and then I want to show them what I fixed, they can actually drop both my fonts into the same tool and see what the differences are. I'm going to skip all that. So let's look at cluster. I was talking about cluster. I choose the script as Tamil, and default language, Tamil is only used to write Tamil. I can look at all the vowels to make sure they're all in, because this tool doesn't look at what's in the font. This tool actually presents the required characters for the font to render the particular language, and then picks those from those fonts. And if you don't have those characters defined or drawn, you will probably see a tofu or a box. Then you'll know that something is missing. This is single character, single glyph. But when you look at consonants, you will see single character or multiple characters that constitute a cluster. So these are consonants, and on the left you'll see all this vowel signs. So I can add a vowel sign to see, and it shows in different colors. If you see that, if you sense that it's distracting, you can turn off the colors. What's important are these things. This actually adds a mark. This is another mark that goes on top. Virama, this is also another mark. But these things actually these marks ligate the base consonant. This is a single glyph, but constitutes of 2 different characters. They are substituted. And it goes all like that. And you can see this is a mark that goes to the left of the base letter. This is a mark that spans both the left and right side of the base letter. You can do all kind of this, and these are things that are required. If any of this shaping is not right, then there's something wrong with the font, or there's something missing in the font. Now, I've got many other tools. One of the things I like to show you is this called String Viewer. Here, you can check some aesthetics, very similar to what Font Goggles does, but it does a little bit more. As I said, I was doing this for AAT, but now I've re-updated it, and it supports OpenType as well. Now, if you see the blue glyph and the green glyph, they're actually the same. They mean the same. They're ta in Tamil. But the first one has a shorter tail than the blue one has a shorter tail. That's because it's actually accommodating the descender of the previous character. And this is shaped with Cortex, which is the built-in default shaper in macOS. Now, the tool also lets you shape it with another engine called the half-pass engine. And with that, if I look at the, sorry, I'm going back to my string viewer. And instead of Cortex, if I use half-pass, can you see that the tail is not substituted? So how do I fix this? You know, so half-pass doesn't seem to handle this, but anyway, half-pass already fixed it. This was a half-pass bug. I was able to find out. So if I ship this font, it will probably show this behavior in Adobe applications. It may work well on Apple applications. So I'm able to see across shapers the behavior of my shaping rules. Now, there's one other interesting thing before I switch on to the next idea. Now, here's a string. Oh, I'm sorry. Somebody, that's my phone number. I hope nobody caught that. Here's a string that you can type. This is actually an incorrect order of typing, but some of Google's input tools allow you to do that, which is wrong. My input methods will actually cut off all these things. It will probably tell the user this is incorrect. But Google input tools allow you to do this incorrect orders. And this is shaped with half-bus. It doesn't show any problem. It looks like the character is correct. But if you actually go and use a correctly functioning input method and search for this character, you will not be able to find it because it's actually wrongly ordered. Half-pass doesn't show the problem, but if you switch the shaper to Cortex, you see the problem because it should not be ordered the correct way. So these are all the kind of issues that you can put in, analyze. If a user comes back and say, why am I seeing a dotted circle when I'm just typing it right, you'll be able to figure it out easily. Well, that's basically the idea. There's also a trace viewer for those engineers who want to look at the shaping process, every step of the way, which lookup is being called, and why some lookups are not functioning, why some substitutions are skipped, probably because they're put in the wrong feature code. All that information can be sought. So this is a brief demo of Hibizcus. It's free. Download it on your Mac from the Mac App Store, and let me know if you have any questions. So I'm going to continue talking. Okay, you've seen the demo. Now, my next project. Now, most of the tools that I use, or in fact, all the tools that I use, except for the latest glyph version, I've not used FontLab for a long time. But when I open up and say I want a new font, it gives me a matrix with A, B, C, D, E, F. It doesn't even ask me what language I want to do that in, right? And I find that drawing or developing a font for Latin from scratch and developing a font for any of the scripts that I talk about from scratch needs a different approach, needs a different paradigm. Because we don't want designers to be concerned about shaping process, writing open type feature code before they can even see a very common character, like in Devanagari, the ka is a common character, ta is a common character, common glyph. We call it glyph, but the user is common character. But you can't get that character show up on your screen without writing at least one open type code, right? How do we test it? In English, or for Latin, we just do a few characters and then look up and see if the design language makes sense before we proceed. But we can't do that for Indian languages without the proper shaping. I'm sure that's the same for Arabic as well, the different contextual forms of the letter. So I thought of doing something different, something crazy. Actually, the idea is to minimize the shaping requirement. In fact, put the shaping into the sketch itself. So let the user sketch without having to worry about what needs to be done to put that character on the screen. So for that, I came up with the idea. I don't know what to call it, so I'm just going to call it a crazy idea. And I look for feedback after I demonstrate this. It's not a finished product. It's a crazy idea product, but I'm happy to show you. Okay. See my face? Right. Okay. What's the first thing, before we even talk about shaping, what's the first thing, how many of us do fonts for languages we don't speak? Yeah, many of us. I'm one of them. When you do languages that you don't speak or you don't write, you need to understand how the stroke flow of the letter for you to better design the outcome, right? You need to know how it's written. So the first thing I wrote, these are all bits and pieces, right? The first thing I wrote was what you call a strokes playground. So this is Bengali. I had this friend, Amrita Sen, she's a great friend of mine. So she wrote this letter. I want you to pay attention to I don't want to scribble here because it's going to disturb the thing. The first line, there's one that goes like an R. There's actually a straight line. The character before that, a triangle. So typically I thought it's just written like go straight down and go up, and goes like that. But that's not how it's written. So you can actually play the stroke flow. Come on. Yeah. Can you see the strokes playing? So as they write, I capture the movement and save it inside my strokes playground. And can you see that? The stroke actually went this way and not this way. Right? So actually, it's a very simple example. There's another one for Devanagari written by my friend Pooja. There's a mark on top of the first letter. I usually thought it goes from bottom up, but that's not the way it's written. It's actually written top down. Yeah? Look at the mark. Oh, it went on very fast. So anyway, that's how I learned how the strokes are written. And then I took the idea and put it into this one. I hope this is the correct one. Yep. And I've got my consonants and vowels. And before I started drawing this letter, I want to know how this is written. And I have a stroke animation. Hold on. Okay, something is missing. Play stroke animation. This is a standard way of writing this letter. This is how it's taught to children in schools. This is a standard formal way of writing a letter. There's also an informal way of writing the letter where the entire letter is written in one stroke without the lift of a pen. I'm trying to capture that as well, so you can see both the formal and the informal way. Now, I use this, because I draw all the letters with my pencil. I'm not going to do it here because my hands are shaking. So I have sketched like 4 letters and 1 mark that's on top. For the mark to go on top of the letter, in a normal font design process, I need to put on the anchor points. If you're using glyphs or even FontLab, you need to put on the anchor points for the base letter and anchor points for the mark for it to snap on. Now I use some natural intelligence, not artificial intelligence. I use some natural intelligence to position the marks automatically, right? So by just doing 4 letters and 1 mark, I can already preview my font in the tool itself. So this is actually a text view. I can actually touch and type. Am I in Tamil? No, I'm not in Tamil mode. If I'm in Tamil mode, okay, if I type something is missing, which is one reason why I don't like to live demos. But trust me, you can actually type ka. What it did was, it took all the characters that are defined in my font and then digged the word list that I've included it from the Hibizcus product that I demonstrated. It's got a word list of about 500,000 words for each language that I support. It looked at all the words that can be written with just these characters and then build up the text, sample text for you. So you can see if your design actually makes sense and then continue with that, right? Then after that, once you're done, you can export it into an OpenType font. You can test it just like how I tested it, or you can export it into a glyphs file, right? And do that in glyphs. Yep, Jerry's there. And then I'm going to finish it by and when you export it into glyphs, right, you see this, you'll see all the colors, the codes. And of course, you can export it into OpenType and install it on your machine, but if you export it, it shows you all the color codes. Typically, what I do when I'm designing all the consonants in different color, marks in a different color and all that. And then even the anchor points are also imported. If you import a TTF file, you won't see all this information, but those things are. So you can now continue with whatever tool that even FontLab reads glyphs files, can do that and finish your font without writing code. I won't say single line of code, but that's the goal, but generally you can finish your font without writing your code. And OpenType will be done for you. This is how it shows your feature code. Yeah, the feature code and all that. Okay, so that's just a crazy idea. that I have. And please feel free to have a chat. If you have an idea that you think will enhance further, and if you're not going to charge me for it, please come and talk to me about it. Thank you very much.
Thank you for this very inspiring talk. We can take some questions.
As someone who speaks none of the languages or reads the scripts, I'm curious if there's any overlap between what you're talking about and what we were just hearing earlier about CJK AI development.
Sorry, you were saying?
With what was spoken about earlier with using AI to develop CJK scripts more quickly, is there any overlap in technique between those systems?
Okay, good question. So far, I have not used any AI for my work. Hibizcus tool has a lot more data in there, language-based data, but they're all natural intelligence. They're all hand-coded word lists, rules, grammar rules, and all that stuff. But I'm not using any AI. But what where I can see leverage point is the focus there is on elegance, on rendering the things beautifully, spacing and all that stuff. They are all valid. I'm not focusing on that yet. I'm focusing on the rules of rendering that script correctly. So I'm sure there will be a point of leverage where we can benefit from the work that they are doing.
Hello. Yeah, it's quite interesting to see the work you have made for the Indic scripts, or rather Brahmic scripts, because I think it's quite complex and needs some wholehearted work like yours, which you've been doing all these years. So are these tools available for all Indic scripts or rather Brahmic scripts? Or only for certain?
Yeah, the current focus is on Brahmic scripts, which is all of Southeast Asia, which is Laos, Thai, Khmer, and Myanmar, and Indonesian scripts, Balinese, Javanese, Lontara, those kind of scripts. But there is nothing that stops us from doing, like Hibizcus, I was demonstrating the use of Hibizcus for inspecting, to inspect an Arabic font, now how Arabic shaping works. And you can just use it. What I don't have are word lists in Arabic or the script grammar or the rules in Arabic, but the string viewer can just render things like that.
Thank you.
Thank you. Okay. Thank you very much.
Thank you.